Section 15, question 4. Contestants in a quiz have 25 seconds to answer the question. The time is indicated on the clock. The tip of the clock hand moves through the arc AB as shown. Calculate the size of the angle AOB. Well, we know that a full turn is 360 degrees. We know that there's a quarter turn is 90 degrees. Now we can see that we've got 3 divisions within a quarter turn. So 3 divisions within a 90 degree turn, that means that each one of these is 30 degrees. So this angle here will be given by 30, 60, 90, 100, 120, 150 degrees. That's pretty simple. And part A is 150 degrees. Part B says the length of the arc is 120 centimetres. Now quite often questions give us look for the length of the arc. This question is given us the length of the arc. Calculate the length of the clock hand. Right, so this is a question where we're kind of looking to work backwards. So the length of the arc is this, and it's equal to 120 centimetres. So we know that the length of the arc is a bit of the circumference. So 150 out of 360 degrees times pi d. Now what we do know is that that is equal to 120. Now the question is looking for the length of the clock hand. The length of the clock hand is given by the radius. If we can calculate the diameter, we should be able to halve that and find the radius. So it's a bit of working backwards for this question. So the length of the arc we know is equal to 120. So 150 over 360 times pi times d is equal to 120 centimetres. So just write that out again and give myself a bit of space. 150 over 360 times pi d is equal to 120. Now what we're really doing now is changing the subject of the formula to end up with d. So next what I'm going to do is write d is equal to 120 divided by 150 over 360 times 3.14, and just bring all that stuff down and divide. Just be careful as you're entering that stuff into the calculator. So you can do 120 divide and then open up a bracket and throw all that in. Now if you're careful, that will give you 91.7 centimetres for the diameter. So the radius is going to be half of that. So 91.7 divided by 2. And to one decimal place, 45.9 centimetres. So that's the length of the clock hand, because that's given by the radius. Of the circle. Final answer, 45.9 centimetres.